So we're here in GNS3, and as you can see, I have created our topology already. Before we focus on the individual elements, let's first just have a look at the configuration of our Versa nodes, because there's a couple of quirks that we need to pay attention to. So I'm going to go to the GNS3 preferences menu, and I'm going to click on QEMU VMs. And in here, you can see I have multiple different images defined, but the ones we're interested in for this lab are the Versa Analytics, Versa Director, and Versa VOS or VOS nodes with the 22.1.2 image. Now, if we have a look at the Director to begin with, this node is configured with 8 GB of RAM and 2 virtual CPUs. This is really the lowest we want to go for this node. It does consume a fair number of resources. So for a lab environment, I recommend to go with around 8 GB of RAM and 2 virtual CPUs. Now, the only other thing we've changed for this node is on the network side. By default, we have one interface. I've increased that to 2 because we need one for our management network and one for our control network that I'll come on to when we review the topology. So the director has a relatively simple configuration, but what's more interesting is the VOS node and the analytics nodes. So if we take a look at the VOS node, for example, and you may know this as FlexVNF if you're using the legacy terminology. FlexVNF, the naming was replaced by VOS or VOS recently. If we look at the VOS node, we can see that here we have 4 GB of RAM configured with 2 virtual CPUs again. And on the network tab, here we have 6 interfaces. 6 interfaces is somewhat of an arbitrary number, but it's typically the number of interfaces that you would see on a production uCPU device, such as a Versa appliance itself or something like a Dell VEP series. So 6 interfaces is a typical number that we would expect to see in a real-world application, and that's why we've selected 6 here. The important thing to know for the VOS node and the analytics nodes, though, is that those images require certain CPU instruction sets in order to operate correctly. So when you boot the node, if you don't configure anything else in your node settings, you may well receive an error that says there are certain CPU instruction sets not available and that the node can't boot. That's going to depend on your platform that you're running on, right? So what CPU that you have that is running on GNS3. So you may have a problem, you may not, and the number of instruction sets or which specific instruction sets are missing may vary person to person. If you do receive that message, however, you can fix that by going to the Advanced tab and coming down here to Additional Settings and adding those CPU flags as options, which you can see I've done here for my platform. So firstly, I've specified -CPU as an argument, and I've specified host. What this does is this passes through my host architecture, which on this platform is an Intel Xeon processor. It passes through that CPU architecture to the virtual machine. However, in my circumstance, that isn't enough because I'm still missing certain instruction sets. So from there, I've provided a comma delimited list of all of the instruction sets that are missing that the VOS node and the analytics node is expecting. Now, don't worry about which specific ones they are. Versa is very helpful and it will tell you when a certain instruction set is missing and what its name is. So you can just add them here relatively simply. Just make sure that you add a plus to the beginning of each instruction set to know that we want to include that instruction set. So that's just one thing to pay close attention to for both the VOS nodes and the analytics node. If we look at the analytics node itself, you can see here under Advanced and Options, I have the same CPU flag set here. So that's an important thing to pay attention to for both analytics and VOS, that you may well need to add additional CPU instruction sets depending on your architecture. If we just quickly summarize and take a look at the rest of the analytics configuration as we did for the others, general settings, we have 4 GB of RAM again and 2 virtual CPUs. And on the network side, we have 3 interfaces. For this lab, we're only going to be using 2, the management network and the control network. The third interface is typically there if you're deploying a more involved head-end deployment where your analytics is part of a cluster. That third interface can be used for various different cluster services. But in this lab, we're only going to be using 2, but that's why we have 3 defined here. Okay, so with that said, let's have a look at our topology in GNS3. Now, in this yellow box, these components here comprise our simple head-end deployment. So as we talked about earlier, we have our director node, which is in the middle. We have our analytics node, which is going to be a standalone instance. We only have one node which is running analytics for this deployment. And we have a VOS node, which is going to be acting as our controller. So these three elements are our head-end components. Each of them have a connection to a management network. The management network is a network that is basically for management, right? So you will be able to connect to any web interfaces, SSH the devices, manage those devices through the management network. Additionally, they are also connected to a control network. Now, this control network is an isolated network. It doesn't have any external access. This is to enable each of the components to talk to each other to run control plane related activities, right? So it could be sending of log messages to the analytics node. It could be sending configuration from the director to the controller, those types of things. So the control network is just for that. Control, it is the control plane of our head end. Now, on my management network, I'm using a layer 2 iOS image here, which is why the icon is different. The only reason for that being is that I'm connecting it to a production live network, which is in my lab. And I've noticed that if I use this typical GNS3 Ethernet switch, I get some strange ARP type issues. So I'm using a Cisco-based switch here, but really the only thing to pay attention to is the fact that I have this external connection. As part of the setup, we do need to access the director via the web interface. And so in order to do that, I need to be able to access this externally from my host machine. And that's why this cloud is here. You may achieve this with maybe a Ubuntu virtual machine if you don't want to connect it to a production network. So you could add here a Ubuntu VM and then use something like VNC to connect to it and then browse to the direct to web interface from that virtual machine. That would be an acceptable way to do it. But for the purposes of this demonstration and to make it a bit easier, I'm using an external network which is linked to my physical lab network. Now, the controller itself needs to have connections to different transports. The controller is really our entry point into our head-end environment from an SD-WAN perspective. So in this topology, our controller has two additional connections, one to an MPLS network and one to an internet transport, an internet service provider. For the purposes of this lab, this is just a single flat network, so nothing exciting. I'm using 2/24 networks to represent this and two simple Ethernet switches to provide connectivity. And then on the far left in these pink boxes, we have two branch devices. These are going to be our locations in our SD-WAN topology, shall we say. These are both going to be dual homed to both our MPLS network and our internet network. And we'll pick the MPLS network for our staging when it comes to deploying these. So that's it really. That's kind of an overview of the topology itself. It's relatively straightforward. Down at the bottom here, we have the IP schema. So you're welcome to use this if you're following along. I'm using a 192.168.4.0/24 as my management network. This is actually my physical lab network that it's connecting to. So I'm restricted in what that may be. You could pick anything that you want, or you might pick whatever the subnet is on your external network that you want to access the director on. For the control network, I'm using 192.168.0.0/24. And for the MPLS transport and the iNet, I'm using this 172.16 range. So for MPLS, it's 172.16.10.0/24. And for the internet, it's 172.16.20. I have a mistake here, so let's just rectify that quickly. We'll make that a 2. We'll make that a 20. Perfect. Okay. So .10 for the MPLS transport and .20 for the internet transport. And then finally, on our branch side, we are going to have two LANs. They're not really in the scope of this lab, but for simplicity and for consistency, in how you would see this in a real world deployment, I've defined them here. We'll use 172.19.1.0/24 for our branch 1 LAN and 172.19.2.0/24 for our branch 2 LAN. And the IP addresses for each of the interfaces, again, can be found in the box below. Okay, so with that said, let's hop into the terminal or the console of our director node to begin the first part of the setup. Okay, so here we are at the console, at the login prompt for our Versa director. The first thing we're going to do is log in using the default credentials, which is admin for the username and Versa123 for the password. That will take us to the director CLI. And it's the director that we're going to do the first piece of, where we're going to do the first element of configuration. So the first thing we'll do is just establish some basic IP connectivity to make sure that our topology is working and that each component of our headend can talk to each other over the management network. So simply for that, I'm just going to run sudo ifconfig. I'm going to specify my interface as Ethernet 0. This is our first interface that's connected to our management network on our director. And I'm going to give it an IP address. In my case, it's going to be 192.168.4.201. It's a /24 subnet, and I'm going to specify up to bring that interface up. I'll enter my admin password again. And now that interface should be available to us. Ethernet 0 with the IP address 192.168.4.201. Let's try and ping the default gateway of this network, which is on my physical infrastructure. So I'm just going to ping 192.168.4.1. And as you can see, we're getting a response. So that means that at least we have reachability to our external network from our director instance. Let's now hop over to our analytics node and do the same thing here. So I'm going to log in with the same credentials, admin for the username and Versa123 as our password. And I'll run the same command here, sudo ifconfig, specifying Ethernet 0 as the interface to configure and giving it an IP address of 192.168.4.202 with a /24 subnet, and I want to bring the interface up. Now I can just run ifconfig to make sure that that has indeed come up, which it has. So let's try and ping again our gateway. Excellent. And as you can see, we have connectivity there. Now let's see if we can establish some basic IP connectivity between the director and the analytics node. So I'm going to ping 192.168.4.201, which is our director instance. And excellent, I'm getting a response there. No need to do it from the director backwards because I'm receiving a ping. So it's implied that that connectivity is available. Finally, let's jump onto our controller and we'll do the same thing here. So we'll log in, again, admin username and Versa123 for our password. And I'll do sudo ifconfig ethernet 0 192.168.4.200 /24, and we'll bring that interface up. Now let's ping 192.168.4.1, which is our gateway, and we have connectivity there. And let's try pinging 4.201 for our director. That's available. And 202 for our analytics node. That's available as well. Excellent. So we've established basic IP connectivity on our management network between each of our headend components. Now, one thing I want to mention just before we go much further, and that is around the interface mapping on the VOS nodes. Now, the controller itself is actually a VOS node, so it's the same image that the branches are both running. And in the VOS infrastructure, the first interface that is available is the Linux management interface. It is an interface that is available to the Linux kernel, the Linux subsystem. It's not used in the Versa topology. So when you look at our Versa interfaces, such as VNI00, VNI01, they start at the second physical interface available on that platform. So if we were to look at our controller and just look at the ports, you could see that Ethernet 0 here is going to my management network. That is the Linux interface. And the rest of them are all going to, these will all be mapped to the Versa virtual interfaces, the VNIs. So VNI01 will go to, VNI00 will go to Ethernet 1, VNI01 will go to Ethernet 2, and VNI03 will go to Ethernet 3. I've done that wrong, sorry. VNI00 will be Ethernet 1. VNI01 will be Ethernet 2, and VNI02 will be Ethernet 3. Apologies. On the branches, you'll notice here, if I click connect here, that Ethernet 0 is not connected. So on the branches, we're not going to connect the Linux interface. We are going to use the SD-WAN VNIs as our connectivity method. So we don't connect Ethernet 0 on either of our branches. Just something to pay attention to, something to be wary of when it comes to designing a headend and how you're going to connect each of your elements together. So with that basic IP connectivity established, what we have to consider now is the persistence of that configuration. So specifically for the controller and the analytics node, we have configured that IP address on that interface. However, we haven't made it persistent. So now that we have configured basic IP connectivity on our management network, let's do the same for our control network. Now, one thing to pay attention to here is we're going to establish connectivity on the control network for our director and our analytics node. We are not going to do the same for our controller. The reason being is that when we onboard our controller, when we end up configuring this, we do so in the Versa director. And as part of that onboarding, it will automatically configure itself on the control network. So there's no need for us to do that. So we're just going to configure the connectivity and make sure that it's available on the director and the analytics node for now on the control network. So starting with the director, I'm going to run the same commands as previously, sudo ifconfig. This time I'm going to specify Ethernet 1 as our interface. This is our second interface connected to our control network. And here I'm going to give it the IP address 192.168.0.2. Again, it's a /24 network, and I want to bring that interface up. And let's hop over to our analytics node and do exactly the same thing there. So sudo ifconfig Ethernet 1 192.168.0.3 /24 up. Now let's try and ping our director on the control network. So we'll ping 192.168.0.2. And we have reachability, so that's good. That means that both our control network and our management network are working as expected. Perfect. So we validated the topology now. The next thing to consider is how do we make this configuration persistent? So by me running this command, sudo ifconfig, that doesn't actually make this configuration persistent. So if I were to reboot these nodes now, I'm going to lose this IP configuration. Now on the director, there is, as part of the setup process, a way to make this configuration persistent. But on the analytics node and on the controller, we have to do that manually. So let's go ahead and do that now to avoid any type of confusion later on. So to make this configuration persistent on our analytics node to begin with, I'm going to sudo vi. You could also use nano if you wanted to. Vi is a text editor if you're not familiar with Linux and the Vim text editor. That's what that is. You could run sudo vi etc network/interfaces. And here, this is the configuration file for our network interfaces. You can see here we have Ethernet 0 specified, and it's currently configured as DHCP. So if we were to reboot this machine now, it's going to use this configuration. It's going to attempt to find a DHCP address. It's not going to use the IP address we've just configured. So I'm going to edit this file. I'm going to press I to insert, and you should see a little insert prompt here. Again, if you're not familiar with the Vim editor. And then I'm going to remove DHCP and replace that with static. Now, I've made it a static IP address or a static configuration, but I need to actually specify what that address is. So I'm going to tab in 1, and I'm going to specify the address as 192.168.4.202. My net mask is going to be 255.255.255.0. My broadcast is going to be 192.168.4.255. My network is going to be 192.168.4.0. And my gateway is going to be 192.168.4.1. Okay, so with that done, we have configured Ethernet 0, which is our management interface. Let's now do the same for our control network interface. So on a new line, I'm going to type auto ETH1 for Ethernet 1. This is the same configuration as we have up here. And iface Ethernet 1 inet static. Let's configure our address, which is going to be 192.168.0.3. Our net mask 255.255.255.0. Our broadcast is 192.168.4.255. And our network as 192.168.0.0. And I've realized that that should actually be a 0. We don't need to specify a gateway here. We don't have a gateway on our control network. Our only route out to the real world is on our management network. So with that, I can hit escape to exit insert mode, and I'm going to press :WQ for write and quit, and hit enter. And now our configuration is persistent on our analytics node. Let's go ahead and do the same for our controller quickly. So on our controller, sudo vi /etc/network/interfaces. we are going to change it from DHCP to static. We're going to give it the address 192.168.4.200. Excuse me, the net mask 255.255.255.0, a broadcast address of 192.168.4.255, a network of 192.168.4.0, and a gateway of 192.168.4.1. With that, we can write and quit, excuse me, and our configuration is now persistent on our analytics and our controller. Excellent. So that is the conclusion of our IP reachability. We have established IP reachability on our management network and on our control network for each of the headend components. The only exception to that being the controller on our control network, and that will be done at a later stage. The next step is to configure our director, and for that, Versa have provided a handy setup wizard. So on our director node, I'm just going to clear the screen so we can read it a little bit better. We need to navigate, so CD, to the /opt/versa/vnms/scripts directory. And we are looking for a file called vnms-startup. This one here, vnms-startup.sh. It's a bash script that we can run that will take us through a setup wizard to get our director configured. So I'm going to run that as sudo. So I'll type sudo ./vnms-startup.sh. And it will ask us, do we want to enter the setup? We're going to say yes for this. And the first question is, do we want to set a host name for our system? I'm going to say yes to this, and I'm going to give it the name as we have defined in our topology, which is director-1. Next, it's going to ask us if we want to set up our network interfaces. And you may think, well, we've already done this, but this is actually the point which will make it persistent on the director. It's basically going to do the same thing we've just done on the analytics and on the controller, but it's going to do it for us. So it makes it a little bit simpler. So I'm going to say yes to this option. I'm going to start with the Ethernet 0 interface. It's already found the IP address reconfigured, but in order to make it persistent, I'm going to say yes to this option. I'm going to specify the same details again. So 192.168.4.201 for our IP address, and 255.255.255.0 as our net mask. It will ask us if we want to configure a gateway. I'm going to say yes, as it's our management network, and I'm going to give it the IP address 192.168.4.1. With that, that's our management interface configured. It's going to ask us, do we want to configure any other interfaces? We have our control network yet to configure, so I'll say yes. And this time I'm going to enter Ethernet 1 as our interface name. Again, it's found an existing configuration. I'm going to say yes to reconfiguring that, and I'm going to specify the same details again. Notice this time it doesn't give us an option to configure a gateway. We've already configured our gateway on our management network. We don't have a gateway on our control network. Now, in certain circumstances, you may have more than 2 interfaces on a director setup. That might be for HA if you have a more involved deployment. In our lab, we only have 2 interfaces. So I'm going to say no to configure any other interface. And now we need to assign, or we need to tell Versa Director which interface is going to be our management network, our northbound, and which is going to be our control network, or our southbound. So I'm going to say yes to configuring our northbound interface. And to select our northbound interface, I'm going to enter Ethernet 0, our management network. Now we need to select our southbound interface. This is obviously Ethernet 1. And it will ask us, do we want to configure any other southbound interfaces? We only have those 2, so I'm going to say no to this option. And shortly, it's going to start to ask us about HA communication. Now, in this lab, we don't have a secondary director. In a production deployment, you would typically have 2 director instances, one as an active, one as a standby. And if that were the case, then this option becomes applicable to you. But because we don't have a secondary director, I'm going to say no to enabling secure mode for the HA ports. I'm going to say no to securing HA communication. The next question is whether we want to prompt to set a new password when we log into the director GUI for the first time. Now, in a lab environment, you could say no to this. However, what I've noticed is If you say no, it won't prompt you the first time you log in, but it will the second time you log in. So we're going to have to change the password anyway. I'm going to say yes to get this out of the way with sooner rather than later. Finally, do we want to edit the list of allowed hosts to access the Versa GUI? Now, in a production scenario, again, this would be a relevant configuration. I would advise you do this. But for us, in our lab, we can say no to this option. Now, the setup wizard is going to restart the Versa services. This can take 5 to 10 minutes. It can be a relatively slow process. So let's join back again once the setup is complete. Okay, so our setup is now complete. I'm just going to hit enter to continue. Let's try and access the director on its web interface. So let's log in with the credentials administrator for the username and our good old Versa123 default password. And if you recall, we said yes to changing the password on first login. So we'll go ahead and do that. Our current password is Versa123, and we need to enter something a little bit more secure. We'll go ahead and click change, and then it will ask us to log in once more with the new credentials. Okay, so here we are in the Versa GUI, in the director's GUI. And the next thing to do is to set up our SD-WAN overlay. That's the first part of our configuration. So to do that, we need to make sure we are in the administration tab. We're going to choose SD-WAN on the left and then settings. And we're going to click the add for a new overlay address prefix. Now, the prefix can be really anything that you want. It needs to be of an appropriate size for your SD-WAN deployment. For now, in this lab, I'm going to choose 10.0.0.0/8, something nice and big. Once that's done, that then means that if we look at our topology again, this overlay network is now going to exist between the controller and each of the branch devices on both of our transports. But you may have noticed that this network is available to our controller and our branch devices, but it's not immediately obvious how our director is going to connect to it. Our director does need to be able to access this overlay network to provision devices and push configurations and things like that. So we need to tell the director how it can actually reach that overlay network, which is hosted on our controller. So to do that, we're going to go to the System tab and Static Routes, and we're going to add a new static route. The destination is our overlay network, which is 10.0.0.0/8. And our next top IP address, this is going to be the IP address of our controller on the control network, on our control plane network, which is going to be 192.168.0.1. The description can just be overlay, something meaningful, and we'll click OK to go ahead and add that route. Now we have a static route defined for our overlay network. Now that that network has been added, or now that I should say that route has been added to our director will now be able to access that overlay network. Our analytics node, however, also needs to be able to access that overlay network for the purposes of logging and monitoring. So we need to go ahead and add a static route for that as well. So we'll jump back to our command line on our analytics node, and we're going to re-enter our etc network interfaces configuration file. Here, under Auto Ethernet 1, which is our control network, we're going to add a command which is uproot add -net for network 10.0.0.0 netmask 255.0.0.0 gateway 192.168.0.1. So we are adding this 10 network with a mask of 255.0.0.0 or 8/8 with a gateway address of 192.168.0.1, which is our controller's control network IP address. We'll go ahead and write and quit that. That will make it persistent. Let's also add it on the command line so we can get connectivity straight away. So we'll do sudo IP root add 10.0.0.0/8 via 192.168.0.1 on device Ethernet 1. So now we have that route in there for the analytics node as well. Perfect. The next step in our configuration is to define our analytics node. To do that, we're going to make sure that we are still in the administration tab on the GUI. We're going to go to connectors and analytics cluster, and we're going to add a new analytics cluster. The cluster name I'm going to give it is WAN cluster, which is the default name for our analytics cluster in Versa. Our northbound IP. Firstly, we have to specify the host name and then the management IP address. The host name is important to get correct because as part of the setup, it's going to be generating SSL certificates and exchanging them with the director, and the host name is an integral part of that process. So we need to make sure that the host names are configured correctly. The host name for my analytics node is going to be analytics1. And its management IP address is, if you remember, 192.168.4.202. So with that, I'll click the plus button to add it. And I'm going to change my port to 8443, just because this is what we typically use in production. And on the collector, I now need to specify the southbound IP address. This is the IP address that we're going to be collecting information from. This is obviously our control network. So this is 192.168.0.3. I'll go ahead and add that. And I'm going to specify our collector port as 1234, which is the default in the Versa configuration. So with that, I'll go ahead and click OK. And now we have defined our analytics cluster in the director. The next step is to actually go ahead and set up the analytics cluster. And to do that, I'm going to connect to the director on the command line, this time via SSH. The reason I'm doing it via SSH is simply because we need to edit some configuration files, and when we do that through the console, the formatting can get a little bit tricky and it doesn't always read very well on camera. So we're going to do it through SSH in this instance. You could, however, if you wanted to, continue to do this via the console. To configure the analytics, we need to cd back into our scripts directory. So that's again /opt/versa/vnms/scripts. Oops, sorry, excuse me, I'm not actually logged in. We'll try that again. So I will cd to opt versa vnms scripts. And we're going to cd into a subdirectory here called van cluster config. Then van cluster install. So van cluster config, van cluster install. In here, we'll see several files. We are interested in two of them. We're interested in clustersetup.conf as well as van cluster installer.py. This py file is the actual installation script. It's a Python file, but it's going to take configuration that we specify in this clustersetup.conf. So we need to first edit this file to make sure that it is appropriate for our deployment. So I'm going to do sudo vi clustersetup.conf. And now let's begin the configuration of our analytics cluster. So the first thing we have to do is set the cluster size. It's currently, or by default, set to 2. We need to change this to 1 because we have only one analytics node in our topology. The cluster name we'll leave as van cluster. This is what we set in our GUI, van-cluster. Let's go back here and here. Forward account, we're going to set to 0. We don't have any exclusive forwarders configured in our environment. Forwarder is a separate component of the analytics infrastructure. We only have one single deployment. We don't have any explicit forwarders, so we're going to set that to 0. We'll leave cluster type as standard. And next we see this Versa director heading. This is the configuration of our Versa director. So we'll leave the director count as 1 because we only have 1 in our topology. And for our first Versa director, we need to specify the username, which we will leave as administrator. And we'll leave the password commented out so that we can specify it when we run the script. It's a little bit more secure than typing it in the configuration file. Next, the RPC address for the director. This is the management IP address that's configured. So in our case, it's 192.168.4.201. And the listener address in our topology, this is going to be our southbound IP address on the director, which is 192.168.0.2. Now, Versa Director 2 is commented out. We're going to leave it as so because we only have one director, as mentioned. And then we are going to configure our VAN node. Our username is Versa. This is the CLI account that we used to log in originally. So we'll leave that as blank. Sorry, we'll leave that as Versa, and we will leave the password commented out so we can specify it when the script runs. For our mode, we're going to change this from cluster to standalone, seeing as we only have one component or one node in our cluster. And our host name, we are going to change this to Analytics 1. If you recall, again, when we set this up in the GUI, we specified Analytics-1 as our host name. So we need to make sure that that is replicated here under our host name. Personality, I'm again going to change from Analytics to standalone. And then we need to do the same as we did for the director, configure the RPC address, which is the management interface, and the listener address. Our collector address is going to be the same as our listener address in this topology. We're going to be using the control network for that as well. So we'll specify that as 0.3. And now our collector port we will leave as 1234 because, again, if you recall, that's what we configured here in the Versa director, collector port 1234. Now we don't have a second VAN node, so we're going to comment all of this out. And we need to scroll down, and we should find that our forwarder node is currently uncommented. We also need to comment this out because we don't have any explicit forwarder configured. So that's the end of the file. That looks like a good configuration to me. So I will write and quit that. And then as sudo, I can go ahead and execute the van cluster installer.py. Now it's going to ask me for the login credentials for the director. This is the administrator account. So this is the GUI account. So remember, we just changed that password. You need to make sure you use the new password that you specified. So I'll put that in now. And then it's going to ask for the password for Analytics 1. This is the CLI account, right? There's no GUI. We haven't configured any other account on Analytics. So for now, this is the default Versa 123 password. It's now going to prompt and complain and say that our resources are not sufficient for our analytics node. It's expecting a minimum 16 gigabytes of memory and additional cores and disk. Because this is a lab setup, that's fine. It meets our requirements for this topology. So I'm going to say yes to continue. And now it's going to run through the setup process. This can take between 10 to 15 minutes, depending on your system. We'll continue once the setup has completed. Okay, so our van cluster install is complete, sort of. There's a little bit more we need to do. We need to run the same command again, but we need to specify a couple of additional options. These additional options are going to set up the communication between our director node and our analytics node, so that when we navigate to the analytics tab on our GUI, on our director GUI, we'll be able to see the analytics interface and the data that it's collecting. Currently, that's not going to work for us until we run this post setup command. So I'm just going to clear the screen so we can see afresh. The command is the same as we just ran, sudo van cluster installer.py, but we're going to specify --post -setup. And we're going to also specify --gen-vd-cert, or generate Versa Director certificate. This is going to, like I said, create certificates and synchronize them between the analytics node and the director node so that we can enable that communication in the director interface so that we can have one single portal to access all of our information. I'll go ahead and hit enter. I'll specify the credentials again for our director and for our analytics node. And now this is again going to take 5 to 10 minutes, possibly even 15. So we'll join again once the setup is complete. Okay, so our post setup procedures are now completed, but before we continue trying to access the analytics host, let's first continue with the configuration of the remaining components. Okay, so next let's go ahead and configure our controller, the third part of our head-end deployment. We're going to click on workflows, and we're going to make sure we are in infrastructure controllers, and we're going to add a new controller. Now, for the name, I'm going to give it controller 1, same naming convention that we have for the node in GNS. We don't have an initial organization, so let's go ahead and click add new. I'm going to name mine just lab. Make sure the global organization ID is 1 for this. We can choose default or services plan. Everything else can kind of stay as it is. I don't want to select a preferred software version right now, but we do want to look at analytics clusters. And yes, I think this is a bug in the current version, or at least in this version, right, 22.1.2. It says there's no analytics cluster configured. There is, because we've just configured it, but it's not appearing here for whatever reason. So that's fine. It's not important right now. We can just go ahead and click OK to create our organization. And with that created, we can now proceed to configure the rest of the workflow. The next thing to note, or the most important thing here, is to make sure that our global controller ID is 1. Now, if for some reason you were trying to configure this before and you cancelled out of it or something, this may not be 1. This may have incremented to 2 or something like that. That's just the director keeping a cache of these controller IDs, and it doesn't clear them out as often or not as quickly as you may have tried to reconfigure it. So if you're configuring your first controller, make sure that the global controller ID is 1. If we don't have a controller with an ID of 1, then things aren't going to work. So make sure that you check the number here. We'll enable it as a staging controller. And then we need to specify the management IP address of it. Make sure that the reachability is there already, otherwise you're going to get an error. I'm going to type in 192.168.4.200, and you can see when I click away, it's going to try and connect to that device. It will only let you continue the workflow if it can establish connectivity, because it needs to discover how many interfaces it has and what model it is and things like that for when we come on to configuring interfaces. So I was successful in establishing connectivity, and now the next button down here has gone has highlighted, shall we say, or it's been enabled. We don't need to configure any peer controllers for this, nor any sub-organizations. So I'm going to go ahead and click next. Analytics cluster, we're going to choose our WAN cluster that we just created. Location information, you have to, at minimum, provide a country. So I'm just going to put the United Kingdom, which is where I am. Oh, missing a space. I will choose next. Now, control network. Control network, this is the southbound interface on our device, right? So if you remember correctly, we didn't configure that on the command line like we did for the director or for the analytics node. This is where we're configuring that interface for the controller. So we can give it a name. It could be anything. I'm just going to call it control. Interface is going to be VNI00. So if you recall from what we said in the beginning, the first interface on a device is going to be the Linux interface, if you like. It's the management interface. And then subsequent interfaces from there are assigned to the Versa process. So VNI00 is the first interface in the Versa process. That equates to Ethernet 1 on our controller, right? Because Ethernet 0 is our Linux interface, our management interface. And then from there, all the subsequent interfaces are Versa controls. So VNI00 would map to Ethernet 1. So we'll choose VNI00 as our as our control network interface. We can leave the VLAN ID as 0. We don't have any VLANs configured on our control network, but we do need to give it the IP address. And the IP address that we selected was 192.168.0.1/24. We don't want to assign this IP address through DHCP. We don't need a gateway because we're not routing outside of that network. And we don't need any routing protocols because, like I said, we're connecting directly to that network. We don't need to reach it through any other hops or any type of routing. So we'll go ahead and click next. And now we can specify our WAN interfaces. So our WAN interfaces are E2 and E3 on the diagram here, right? Which equate to VNI01 and VNI02. VNI01 is going to connect to our MPLS network, and VNI02 is going to connect to our iNet network. So let's go ahead and configure those. So I'll add a new network on the right here. I'm going to choose VNI01. VLAN can stay at 0. Network name, we need to add a new one. We're going to call this MPLS. And for transport domains, Versa has 2 out of the box. They have MPLS and Internet. So we'll just choose MPLS for this because it is an MPLS network. And we'll click OK. There is no public IP address. We do want to use it as a staging network, right? So we can onboard devices over this network. The pool size, I'm just going to bring this down to 16 for this lab because we don't need that many. We don't need to be able to provision that many devices, or we don't need to stage that many devices on this network. And then the IPv4 address, let's have a look. So for Ethernet controller 1 on E2, controller 1 E2, which is the MPLS network, we're using the IP address 172.16.10.1. So let's stick that in there, 172.16.10.1. There is no gateway, there is no FQDN. I think this is red because it's expecting /24. Yes, it is. And we're not using IPv6 in this lab. So we'll go ahead and click OK. Then we need to add another one, which is going to be on VNI02. This is going to be our iNet. Oops, excuse me, iNet. We're going to use the internet transport domain for that. Again, no public IP address. We do want to enable it for staging. We'll reduce this to 16, and the IP address here is 172.16.20.1. So 172.16.20.1. Perfect. Okay, now we have both of our MPLS and our iNet transports or networks configured. So we can choose next. We can review the configuration if needed. I'm quite happy with this, so I'll go ahead and click deploy. Now it will take a couple of minutes for the controller to successfully configure itself. We may see some output on the command line, we may not. We can confirm what the status of the services are by running VSH status. You can see at the moment everything is running. It will probably restart this node. Oh, let's have a look here. Why did this fail? Failed to connect. Okay. Let's just make sure that we have that reachability. This is a quirk, I think, of my GNS topology. It's not expected, right? Okay, so let's go ahead and we'll just edit, and then we'll skip to review. Excuse me, we'll exit that. We'll skip to review and deploy that again and see if we have more success now. Sometimes for me, I need to kind of keep a continual ping going in the background just to make sure that that connectivity doesn't disappear. I think it's because I have this network connected to a cloud, and there's probably something funky going on there that I haven't worked out yet. So that's on my end, and I apologize for that. But I think we're nearly there. We're at 70% now, so I think it's working. It's working. We'll let this complete, and then we'll continue once our controller is up. Okay, excellent. Our controller is deployed. That's what we were hoping for. We could go to administration and appliances, and we can see our controller 1, which is up with for reachability, and configuration is in sync. So that's our controller configured. That is all of our head end now deployed. We have our director instance up and running. We have our analytics instance up and running, and both of them talking to each other. And we have just configured and onboarded our controller with the 2 MPLS and iNet transports. So now we can confirm this is working by onboarding a couple of branch devices, and that will be the final part of this lab. In order to do so, because this is a fresh head-end deployment, the first thing we need to do is go ahead and create a template. So I'll go to Workflows, Templates, and I will add a new template. We'll call this something like Simple Branch. Nothing fancy. And this will be a SD-WAN post-staging template. Now I'm going to leave the device type as SD-WAN full mesh. The subscription, I'm just going to put Premier Secure SD-WAN, 5 megabits per second and 1 year. This can kind of be whatever you want for the lab, for the purposes of this lab. Our organization, I'm going to choose lab, which is the one we created, the only one we have. And I'll choose stateful firewall for our firewall service. Now, controller 1 is already selected. Obviously, we need to have at least one, but if you had more than one controller, you could add additional ones here. I'm going to leave that blank because we only have the one. So I'll go ahead and click. Actually, if we scroll down, sorry, there's a little bit more. We don't have any redundant pairs to configure in this. We can select our analytics cluster as our WAN cluster. I want to leave preferred software version as it is. If I select the latest version of 22.1.2, it's going to complain that I don't have all the images because I don't currently have a WSM image in this lab. So I'm going to leave this as please select. You don't have to set that. And then I'm going to go ahead and click next. And now we can configure our interfaces. So let's go ahead and add our first interface, or we can click on the first interface here, 0, and choose WAN. So if we have a look at our GNS topology, Ethernet 1 or E1 is connected to our MPLS network on both branches. So we'll choose VNI 00 as our WAN, first WAN interface. We don't care about the VLAN ID, and the network we're going to attach it to is the MPLS network. Our IP address is going to be static for IPv4. We don't use IP version 6 in this lab, so we'll leave that at 0. I'm going to leave priority as it is, but I'm going to choose circuit type as IP and circuit media as Ethernet. Don't care about tags or circuit provider for this, and the rest of the fields we can also leave blank. So I'll go ahead and click add. Now I'm going to click on 1 up here because I want to add a second WAN interface, and this is going to be our iNet interface. This is VNI01. So our network name is going to be iNet. And again, static IPv4, no IPv6, ignore priority, circuit type to IP, circuit media to Ethernet, and the rest can remain blank. So we'll go ahead and click add. Finally, we're not really using this in this lab, but we'll go ahead and configure Ethernet 2 as our LAN interface. We can specify a network name. We'll call this branch LAN. And we can leave the rest of this blank. I'll enable DHCP in case you want to connect a device to it in future. I'll go ahead and click add, done. And now we have our two WAN interfaces, MPLS and iNet, and a connection to our LAN network. I'll go ahead and click next. For this lab, we're not configuring any tunnels, so we'll click next. We don't have to worry about any routing on our interfaces, so we'll go ahead and click next. Inbound NAT is not applicable for this lab, nor is management servers, so we can go ahead and just review this and click deploy. Once this template has deployed, we can now go ahead and create our workflows for our two branch devices. So while we're in the workflows tab, we're going to choose devices and then devices, and we're going to add our first device. Now the name for this one is going to be branch 1. We'll onboard branch 1 first. Global ID we can leave as the generated one. Organization is lab. Deployment type CPE bare metal device is what we're going to leave it as. Serial number, for simplicity, I'm going to specify my own serial number. If we don't specify something, it will generate one, but we need to know that serial number for when it comes to the onboarding. So for simplicity, I'm just going to set the serial number to the same as the actual branch name. Device group, we don't have one yet, so we can click on add new. We'll call the device group GNS3, for example, so we know that these are branches that are within GNS3. Organization can remain lab. Post-staging template is going to be our simple branch, and the rest of this I'm going to leave blank for this demo. Perfect. Model number I'll leave blank as well. Contact I'll leave blank. Subscription we can remain as 1, and service bandwidth I'm going to set to 5 and choose next. I'm going to set United Kingdom as the location of my device and choose next. Device service templates, we don't have any for now, so we'll choose next. And now we have to configure a little bit of bind data for our WAN interfaces. So our LAN, what is our LAN IP address? Let's go back to GNS3. So for branch 1, our LAN interface is Ethernet 3, and we've chosen 172.19.1.1. So in here, I'll put 172.19.1.1/24. Our iNet, our internet IP address, is going to be Ethernet 2 for branch 1, which is 172.16.20.10. And for MPLS, it's 172.16.10.10/24. Perfect. Now let's click on the left. You see there's different elements of bind data that we need to configure. We'll choose virtual routers. Now, we have to specify a gateway address for each of our transports. In this lab, we're just using a single flat network. So for now, we'll just specify our gateway as 10.0.20.254, for example. Let me just make sure that was the right network. Oh, sorry, 172.16. I've already forgotten. And for for MPLS, 172.16.10.254. Now for DHCP, what DNS server do you want to use? We'll just choose 8.8.8.8. Our IP pool can begin at 5 and, 19. And it can end at, 254. There we go. That's a decent amount of addresses. So we've configured our bind data. We can go ahead and click next, and then we can review and deploy. Perfect. So now we have branch 1 here. Now I've just got to do the same thing again for branch 2. So I'll specify the name as branch 2. I'll set my organization to lab, and I'll configure the serial number as the same as the name as branch 2, and use the GNS3 device group we just created. I'll choose 5 megabits per second as my service bandwidth and click next. I'll just put in United Kingdom as our country. No service templates. And then for bind data, we'll just run through this again. So this is going to be 172.19, .20.1/24. 172. INET. Sorry, I've forgotten that again. INET for branch 2 is E2, 20.20. And then MPLS is 172.16.10.20/24. Virtual routers will go 172.16.20.254 again. Sorry, next hop on 172.16.10.254. And for DHCP, we'll go 8.8.8.8 for DNS. We'll go 172.19.20.5 for the starting range, and 172.19.20.254 for the end range. Again, we're not really using this in this lab, but because I ticked DHCP, we need to specify it. We'll click next and deploy. Awesome. So now we have our 2 branch devices, or at least defined in the director. Now let's go ahead and attempt to onboard them. Let's go to the console. Sorry, let's go to GNS, and we'll jump first into our branch 1 device. We'll log in as admin and Versa 123. That'll be drummed into your heads by the end of this. I'll just clear this so we've got a nice clean slate. And so when it comes to onboarding this device, we just simply need to execute a script. That script is located in opt Versa scripts. And if we do an ls, we're looking for one called staging. Here it is. Now, there's various options that you need to specify here. We can do sudo./staging staging.py --help, and you will see all of the options that you need to configure. There are a lot. For us in this lab, we only need a few of these. So I'm going to run the command as so. I'm going to, in fact, I will type this out so that you can see it a little bit better, because I don't think it's going to show up properly in the console. So we're going to run the command staging.py. We are going to specify -n, which is the serial number of this device that we want to onboard. Branch 1 is the name I gave the serial number for branch 1 in the director, right? So if we go back to the director, branch 1, you'll see here serial number branch 1. So we need to make sure that these 2 numbers match. Going back to our notepad. The next is -w. This is what WAN or which WAN interface you want to use to perform the onboarding. When we say WAN interface, this is which Versa managed interface we want to use. So this is not the first physical interface. Remember, the first physical interface is the Linux management interface. So by specifying -W0 here, what we're actually saying is use VNI00, which is going to be E1 in this diagram and our MPLS interface. So we're specifying -W0, so we're going to be using our MPLS interface for onboarding or for communicating with the director. And then we specify -S, and what subnet, what IP address do we need to configure on that interface to communicate with our controller? Well, for this device, it is 172.16.10.10/24. And then we specify -C, and we provide the IP address of the controller that is on that network. So this is the MPLS interface of our controller. That is 172.16.10.1. Next, we specify -R, and this is the remote identity that we specify the remote identity that we're connecting to. So to find the remote identity, we can go back to the director, we can go to administration, and we can make sure we're in appliances and click on controller 1. From here, we can go to configuration, services on the left, IPsec, and VPN profiles. And because we are onboarding on the MPLS network, we can find this MPLS controller 1 staging. So we're interested in the MPLS transport VR here, right? So find the VPN profile that is associated with that MPLS interface and go ahead and click on it. And from here, you can click on the IC tab, and you will see, if we scroll down a little bit, or when it populates, there we go, you will see that in the email identity, this is what we need to specify, controller-1-staging@lab.com. So I'll copy this, and this is our remote identity. And then we need to specify -L, and this is our local identity. Now what you can do is just specify the default one provided here, which is, you see this remote ID, SD-WAN-branch@lab.com. So we'll go ahead and use that. SD-WAN branch, if I type, at lab.com. Now, the final thing we have to specify as a mandatory attribute is the gateway. We don't need a gateway, so for this, we'll just put 172.16.10.254. And now this should be sufficient to onboard our branch into our header, onto our SD-WAN topology. So let's copy this. Let's go back to our command line. We'll just clear the screen again, and let's go ahead and execute that. So I'll hit enter. You can see that it's accepted the configuration, it's loading it, and hopefully shortly we should see a task pop up in the director that is onboarding the device into our topology. So let's go ahead and take a look. We're in the director. We can click on tasks. And here you can see that the system is now creating a bare metal appliance. It is now onboarding our branch 1 device, which is exactly what we're looking for. Let's go ahead and do the same then for branch 2 while that's completing. So in this case, we're going to change branch 1 to branch 2. Our IP address in this case is, instead of .10, it's .20. Control is the same. Everything else actually remains the same. So we'll copy this. We will connect our console to branch 2. Login as admin in Versa 123. Remember, we need to cd into, opt Versa script, and then we can execute that staging script as sudo, and we should now onboard branch 2 as well. So we'll just let the configuration build. And once this is completed, we'll go and see if we can find it in the director. Okay, perfect. So we see that it's completed. Let's go back to our director. We'll refresh. And now we can see we have successfully onboarded branch 1. And we are currently in the process of onboarding branch 2. Perfect. This is excellent. This is exactly what we needed. So once this is done, we can run through a very simple check to make sure that we have reachability between our 2 branches. And that is the creation and deployment of a simple Versa HeadEnd complete. So let's go ahead and look go back to administration and if we go back to director view, appliances, we can now see we have reachability to both our branches and our controller, and our configuration is synced, which is exactly what we wanted to see. So now, more than likely, both these branches are going to go through a reboot, which they're coming up. So we'll give them a few minutes to initialize, and then we'll do a basic connectivity check to see if we can get a ping between both branches. And then that would conclude the head-end deployment. Okay, so here we are on branch 1. And let's just run some simple connectivity tests to make sure that our infrastructure is up and running. Let's jump into the Versa CLI by entering a CLI and hitting enter. And here, let's try and ping the MPLS WAN address of branch 2. So here I'll do ping 172.16.10.20 routing instance MPLS transport VR. And you can see that we have reachability to branch 2's WAN IP address. Let's try the same, but on the iNet. So we'll do 20.20 routing instance iNet transport VR. And again, we have reachability. So that proves that our connectivity, our basic connectivity, is now up and running. We have the devices enabled and accessible in the director. This reachability is likely because it's just finished rebooting. So yeah, they've just finished rebooting, so it'll take a second for that to reflect accurately. The very last thing for us to check is that we are seeing data in the analytics UI. So let's go ahead and click on analytics in the director. And we can see both of our branches and our controller up. We can see bandwidth running on the different circuits, which is excellent. We can also see various log messages from both branch 2, controller 1, and hopefully in here somewhere branch 1 as well. There you go, branch 1, which means that all of the components are talking to analytics and we can access it through the director. So this again validates that our head end is deployed successfully, and that's the end of this lab.